The first topic in section 11.6 is absolute convergence and conditional convergence. The series sum of a sub n is absolutely convergent if this series is convergent. What this series is what you get by taking the absolute value of all of the terms of a sub n. So let's look at an example. Negative 1 to the n plus 1 over n squared. N goes from 1 to infinity. If we take the absolute value of this, well, before we do that, let's write this out. This is an alternating p-series. When n is 1, we'll get negative 1 to the second power, so we get 1 minus a fourth plus 1/9 plus minus 1/16 plus 1 over 25, etc. So if we take the absolute value of these terms, what we've got is just 1 over n squared. And this series, of course, is a p-series. P is 2, and so this series converges. That tells us that the original series up here is absolutely convergent. The best way to think of absolutely convergent is this. Absolutely convergent means that the series converges even if we take the absolute value of all its terms. Let's look at an example that's not absolutely convergent. In the previous section, we saw that if we take the alternating p-series, or the alternating harmonic series, like this, we saw that this series converges by the alternating series test. However, if we take the absolute value of these terms, and that would just get rid of the negative 1 raised to the power, we get this, which is the harmonic series, which diverges. So what that tells us is this series up here is not absolutely convergent. It's conditionally convergent. Let's look at another example. Let's look at this series. Let's say we have negative 2/3 raised to the n power. This is a geometric series. R in this case is negative 2/3. If we take the absolute value of that, it's less than 1. Therefore, it converges. So we know the series converges, but now my second question is it absolutely convergent? Or conditionally convergent? Well, to find out, take the absolute value of the terms. Now, to take the absolute value, all we have to do is get rid of the negative here. So we just get 2/3 to the n. This is still geometric. The ratio is now 2/3, which is still less than 1. And so therefore it's convergent. So since the series here where we took the absolute value, since this series is convergent, that tells us that this series up here is absolutely convergent. One thing I should also mention, this series down here that we got after taking the absolute value, it's also absolutely convergent. If a series has all positive terms and converges, then it is absolutely convergent. And that makes sense because when you take the absolute value of the terms, nothing changes if they're all already positive. Let's do one more test, or one more example. 4. Cosine n over n squared, or n cubed. Actually, let's don't do this. Never mind.